I want to talk to you about koala. So, in a very short description, koala can detect problems in your source code and can also fix some of them. But in order to understand what makes koala different from all those many tools out there, let me ask you a question. Would you rewrite LibreOffice only to get spell checking for Portuguese or for German? Please raise your hand if you would love to do that. I guess so. And now let's take a look at the world of static code analysis. In the world of static code analysis, we have a hell lot of tools. And every tool does some static code analysis for some language. Some also cover several languages. But if you want to have your whole project covered, you're gonna need several tools. Or there even exist tools that wrap all those different tools. But the problem is bigger than that. The problem is not only for the users who cannot use all those tools because they have to learn all of them again and again and again. The problem is also for the developers, because the developers have to rewrite the whole tool from scratch every time. And that leads to different interfaces. It leads also to smaller projects not covering all use cases of the users. A user might want to run code analysis from his editor, from the command line, from the continuous integration, or he wants to export it to JSON for scientific purposes. If we look at static code analysis written by scientists, it'll be totally unusable because they don't care about the usability. They just want to write the logic. So, solely drawing this graphic sucked. And I'm not speaking about implementing all those connections for all those different tools, for all those different languages, to all my tools, my output formats as a user, what I prefer. Let's enter koala. Koala is one API, essentially. Koala is an API that defines how a code analysis result should look like. And on top of this API, Koala gives you applications that cover all your use cases, that cover JSON output, that have a browsable HTML page of your results, and all that. And right now, Koala supports code analysis for 54 languages, and that number is counting every day. And because I told you the goal is to reduce the redundancy across code analysis, what we do is we integrate those tools that already exist. And to be sustainable, we allow you to write custom code analysis routines without having to worry about anything else than just the logic. We also support you if you, for example, want to parse an AST and consume it in multiple other routines. We parallelize the analysis. We cache it. We make it fast for the user. We make it easily configurable. We provide the usability. So as a user, you can use one tool to analyze your whole project, which has 5 different languages. And as a developer, you can stop writing your tools and spending half of your time on the actual usability. So we're at a developer conference. So let's see some code. Let's see how well this works. So we have an example project. And this example project has several languages, in this case Java and Python. Those are randomly picked by some contributor from Koala. And if we want to perform some analysis, for example on Java, let's take a look at what Koala does for Java. We have a browsable website which shows the supported languages of Koala. You will see that there are some analysis routines that will work for all programming languages, because there's no need to rewrite spacing routines for the new programming language you're inventing tomorrow. And on the other hand, you can have language-dependent code analysis. So let's take a look at what's there for Java. We have, for example, the CPD bear. We call our analysis routines bears because they could also collect statistics, or they can provide patches to fix your problems. So this is the documentation for the CPD bear. We can configure it. We can run it for those languages because the tool below supports it that way. And it searches for redundant code. It tries to find functions that are basically identical, and one of them should be removed. Let's try that. That's something cool, right? So if we run koala, it'll tell us what we need to do. So let's run the CPD bear on all Java files. And apparently there's something missing. The CPD bear needs some configuration from us, so it will be asked from us. We want to do it for Java. And then we can see the results. We can browse the results in this interactive command line interface. And we can, say, open them in an editor and see that those functions are actually the same. It will also detect that they are not exactly the same and all that stuff. Okay, that's all nice and clean, but we don't want to enter a command like this every time. So we need some kind of configuration. Koala can generate a configuration automatically. When I wrote this, I was very frustrated with tools like Make that also complained about how your file was, and they knew the solution, and they just told you to apply it manually, but they knew the solution, so why didn't they do it automatically? Koala asks me for it interactively and saves it directly into the configuration file. I don't need to worry about this anymore. So let's take a look at the generated file. We see this is an ini-like syntax. We can specify the stuff we want to run, and we can specify settings that will be delivered to all those beers in that particular section. Let's add analysis for Python. This is the Java section. And that's the Python section. We can just add new sections. And when we run koala again, it will run all those sections. Here we see that the Java section is run. And now we see that the Python section is run. And in case of the Python, koala can also suggest a patch to make our code better automatically. We could go through the results one by one if we wanted to. We could also tell it to apply all patches automatically. So let's do that. So now we see koala has corrected all our Python files. This is the git diff. Apparently it was not PEP8 conform. But we can do more. We can combine language-dependent with language-independent analysis. We can say, check our Java source code for spaces and tabs, and not having to rewrite this routine for Java specifically. And at the same time, we can check it for code clones, which is a routine that is inherently dependent on the programming language. So we don't want space. We want tabs, because we have spaces. And now koala can fix all our spaces and make them tabs. And at the same time, yes, it can tell us that we have code duplication here. All right, so now you basically know how to use koala. You can apply a lot of static code analysis to your files. You can have different sections for Python. Maybe you want another tab width for make files. You want to use tabs for make and spaces for Python. Just put them into different sections and you're done. You have one configuration file. You have only one tool to learn. You have only one documentation to browse. And you don't need to worry about all those tools. And as a developer, you don't need to rewrite all this redundant stuff. I want to very, very briefly show you how a bear is actually written. Because that is the secret. If you want to make writing static code analysis easy, then you have to make it really easy. And you can't just say you provide an API and somebody has to override some complicated calls. So let's write a bear. Let's write a bear that checks for to-dos in my source code. So we can do this in an object-oriented manner. And Koala also automatically takes care of getting the settings from the user, reading in the files, and I just can modify, I can work with the contents right ahead. And we can just yield our results. And with those very few lines, we have already written a piece of static code analysis. If we wanted to add configurability, we would just add a parameter to the signature of our function. There's nothing simpler than that. If we want the user to see explanations about the parameters, we add a documentation comment. We just write one function. We can also add difference if we want to split it up, but we only have to write this thing, and Koala will take care of all the rest. It's logic only, and the user gets the full usability for free. Okay, that is the most important stuff for Koala. I want to tell you a very, very short bit about Gitmate, which is a code review bot that automatically runs Koala on your source code, on your GitHub projects. And automatically comments on your pull requests. So if we want to enhance your code review with static code analysis, you don't want to look at the ugly CI logs every time. You want to have the comments of the static code analysis in the same location as the comments from the human, so the human doesn't have to do them. This is just one of the possibilities that you have if you have one unified API. Okay, that was my presentation about Koala. Thank you all for your attention. I'm Lasse Schuirmann. I'm a freelance software developer. If you want, you can contract me or whatever. I'm doing most of this in my free time. This guy in the front co-founded Koala. He basically wrote the very first version. Now feel free to ask us anything you want. And thank you very much.